Supplement number 7. Robin flies to San Francisco from Santa Barbara in 3 hours. She flies back in 2 hours. If the wind was blowing from the north at a velocity of 40 miles going, but changed to 20 miles from north returning, what was the airspeed of the plane? Its speed in still air. So above in still air. Okay, so we need to visualize the movement of the plane. Probably Robin is a rich guy. He owns a private jet because he cannot fly right away to a certain location, for example, Santa Barbara to San Francisco, and flies back if he don't own a private plane. Okay, so since he owned a private plane, so he ride from Santa Barbara. So we have our first location. So we have Santa Barbara going to San Francisco. So 3 hours. 3 hours. And she flies back in 2 hours. So from San Francisco, so he flies back in 2 hours. So what is our observation? Did the distance from Santa Barbara to San Francisco change? It does not. Okay. So therefore, we can say that the distance is constant from Santa Barbara to San Francisco. Now, if the wind was blowing from north, okay, so our mnemonics for the direction, we have north, east, west, or south. So news. If the wind was blowing from north at a velocity of 40 miles per hour, here the rate of change of the plane from Santa Barbara to San Francisco is not defined. So we can say that we can assume here a value of our a variable x. Okay? So since the velocity is blowing from north, so if this is the if San Francisco is north and Santa Barbara is south, so therefore we can say that during the flight from Santa Barbara going to San Francisco, he experienced an opposing force, a wind force of 40 miles per hour. So whatever the speed here, rate minus 40 miles per hour because the they are opposing. Okay, how about the second condition? But change 20 miles from north returning. Okay, so here, so it could it additional force instead of opposing, the wind is pushing the plane an additional of 20 miles per hour. So here we can say that it is in a minus condition and here is a plus. Here your speed is being deducted with 40 miles per hour. Here your speed is plus 20 because the wind is blowing going to Santa Barbara. So how can we establish our diagram or our time rate distance? Okay, from the given. So let's recall our time rate distance table. Okay. So the famous. So okay. So let's name here. Our first travel is, for example, Santa Barbara, uh, going to San Francisco to SF San Francisco. Then from return back, from San Francisco going to Santa Barbara. Okay. So here, the speed of the plane in still air is not yet defined. Okay. So let's assume a variable first. Okay. So here, let's assume a variable. So we let So what we let here? So we let x, since we don't know the speed of our plane. That is the speed of our plane in still air, or that is the airspeed. Okay, so we don't know the speed. Okay, so how about the time? So let's write the time. So it's already given. So going sa Santa Barbara, going to San Francisco, that is 3 hours. So going back, that is 2 hours. How about for our speed? Yes. If we assume our speed here is x, therefore our x is being deducted, right? Because the wind is opposing. Okay, so we can say, since we assume our x is the speed of our plane in still air, that is x, what is the opposing force? The wind blows, so you're being deducted. How about from San Francisco going to Santa Barbara? Instead of deduct, it is in addition. So blowing, so additional. So your speed plus 20 miles per hour, the speed of or the wind blowing. So that is x plus 20. Yes. Now, if we apply our formula, time times rate times distance, this will become 3x minus 40 and 2 quantity x plus 20. Okay. So now, did the distance changes? It did not. So the distance from Santa Barbara going to the San Francisco does not change. So the reference of our equation is d1 is equal to d2. Now, we have our d1 r d2 based on the formula. So we can say that 3x minus 40, since opposing, is equal to our distance from San Francisco plus the additional wind blowing, or the wind speed. Okay, so this will become 3x, 4 times 3, 12, 120 is equal to 2x plus 40. So we transpose 2x to the other side, that will become x. 1x. Okay, so negative 120, you transpose it to the other side, it will become positive. So therefore, 120 plus 40, that is 160. So what is the unit of our rate? Is in mile per hour. So our x, or our speed of our plane, what is the airspeed of the plane? That is 160 mile per hour. So if we substitute x to our equation here, 160 minus 40, 20 times 3, that is 360. Again here, x, 160 plus 20, that is 180 times 2, that is 360. Okay, so the both side is equal, so we can say that our answer x, or the speed of the airspeed of our plane, is 160 is correct. Okay, let's move to our next example.